Hello students, today we will discuss Poisson equation and Laplace equation, and we will start with Gauss law. According to Gauss law, the surface integral of electric field intensity over a closed surface is equal to 1 by epsilon naught times of the total charge enclosed within the surface. Now consider this is a closed surface and it is enclosing some charge, and here we consider the charge distribution to be continuous. Charge distribution that is continuous within this charge distribution is continuous within this surface, and that charge density is, let it is rho. Okay, and the surface is closed surface, so it will enclose some volume. So if we take this to be the center origin and suppose this is the radius r, then the volume enclosed by this sphere of radius r, that will be equal to 4 by 3 pi r cube. So here I just want to say that this closed surface will enclose a volume V. If any surface is not enclosing any volume, then it will be open surface. Okay, so if we write the Gauss law in mathematics language, then it will be E dot ds. So this will represent the surface integral of electric field intensity, which is given by the dot product of electric field intensity vector with the surface vector, and over closed surface this is equal to the charge enclosed divided by epsilon naught. So if we, how we can connect this charge enclosed within the closed surface and the charge density? So the total charge enclosed within this surface, that can be given by the volume integral of this charge density over the volume V enclosed by the closed surface S of radius r. So this will give us the charge enclosed. Okay, now if we substitute the value of charge enclosed here, then you will see we can write the right hand side of this equation like 1 by epsilon naught times of the charge density into the volume enclosed by the surface S. Okay, now you see on the left hand side we have surface integral and here we have volume integral. So we are to think about how we can convert the surface integral into volume integral. That we can do using Gauss divergence theorem, and this theorem connect the surface integral and volume integral. Surface integral over closed surface and the volume integral volume enclosed by the closed surface S. So if we have a vector A and we find its surface integral over the closed surface S, this will be equal to divergence of the vector field over the volume V. So this is how we can connect the surface integral and volume integral using Gauss divergence theorem. So if we apply this theorem here, then you can see here the vector field is electric field intensity, and if we use the Gauss divergence theorem here, then we can write the left hand side like divergence of the vector field, that is electric field here, and integration over the volume V enclosed by this closed surface area. So if we compare the left hand side and right hand side, then we can write that divergence of electric field vector, that is equal to charge density by epsilon naught. Okay, so this is how we can find another form of Gauss law, and this is the differential, this is the differential form of Gauss law. Okay, so now we are to obtain the Poisson equation. Now we will make use of another relation, that is the relation between electric field intensity and the potential. So we know that the relation between electric field and potential V, that is electric field is given by negative of gradient of potential. So if we substitute this relation in differential form of Gauss law, then we will use this equation here, and then we will get this relation, divergence of E, and E is equal to negative of gradient of potential. So this will be equal to rho by epsilon naught, where rho is the charge density in the volume V enclosed by surface area S. So if we rearrange this thing, then we will get del square V is equal to minus charge density by epsilon naught. Or if you rearrange this equation, you take it on the left hand side, then you can write it plus this is equal to 0. So this equation is known as Poisson equation. Okay, this is the equation. Okay. And if for any surface Gauss law is very important, here you can see, and we are making totally use of the Gauss law. And we have made a surface, this is the closed surface enclosing volume V, and this was the center, and here is the radius vector R. Okay, if this surface is not enclosing any volume, then what will be the meaning of that? If this surface is not containing any charge, so if charge is equal to 0 within this surface, then the charge density will be equal to 0. It means there will be no any divergence of electric field. Why? Because the charge enclosed is 0. So no any electric field line will emerge out or sink within this surface. This is the meaning, or we can say in this particular case the divergence of E, that will be equal to 0. Okay, so if the charge density is 0, so let me write here, this is the Poisson equation. Okay, and for this particular case the charge is 0 and the charge density is 0, then divergence will be 0. It means that square of V, that will be equal to 0. Why? Because here the charge density is 0, and this equation is known as Laplacian or Laplace equation in electrostatics. Okay, class. So class, this is the Laplace equation, and we will, using these equation, we can find the charge density within any surface or potential in that surface, or we can find, if we can find potential, then we can find the electric field also. Okay, and we can find another relation for displacement vector D, and we will do that in the next video lecture. In this lecture we will limit ourselves up to this point only. Thanks for watching the lecture.